Hey guys, welcome back to the second part of this reinforcement learning tutorial where we teach an AI to play Snake. In the last part, I showed you all the necessary theory that we need to know to get started with deep Q learning. And now we start implementing all of the parts. So as I said, we need to have a game, so the environment, then we need an agent, and we need a model. So in this part, we start by implementing the game, and we use PyTorch for this. So let me actually start by creating a environment, and we install all the necessary dependencies that we need. So in this case, I use Conda to manage the environments. And if you don't know how to use Conda, then I have a tutorial for you that I will link here. But yeah, if you don't want to use Conda, you can also just use a normal virtual env, but I recommend to use a virtual env. And now let's create a virtual env with Conda create -n and then give it a name, for example, Pygame env. And I also say I want Python equals 3.7. All right, so now this was created. So now we want to activate it with Conda activate and then Pygame env and hit enter. And then we see the name of the environment in the front. So this means that we activated it successfully. And now we can start installing all what we need. So the first thing we want to install is Pygame for our game. So pip install Pygame and hit enter. So this is done. The next thing we need is PyTorch for our model later. So for this, we can go to the official homepage and on install. And then here you can select your operating system. So I use Mac. And I want to say pip install, and we don't need CUDA support. So only a CPU is fine. And we don't need Torch audio because we don't work with audio files. So we can only grab this pip install torch vision and then paste it in here and hit enter. And now this installs PyTorch and all the dependencies. All right, so this is done. And then we need two more things for plotting later. So for this, I say pip install matplotlib, and we also want IPython and then hit enter. All right, so this was successful as well. And now we have everything we need. So now we can start implementing all the code. And as a starting point, I want to grab the code from another tutorial that I did. So you can find this on GitHub and then on my account and then in the repo Python fun. And here I actually have two Snake games. So, and then we need this one, Snake Pygame, and download this. So you can do this, and I already did this and have this here. So if we open up the editor, here I'm using Visual Studio Code, then we can see we have exactly those two files. And then the first thing I want to do is I want to run this file and test if this is actually working. So right now this is just a normal Snake game that you have to control yourself. So you have to use the arrow keys. So let's say Python snakegame.py, and then let's hope that this is working. So yeah, so now I can control the snake. And I hope that I can eat the food, yes. And now if I hit the boundary, then we are game over. So this is working, our environment is set up, and now we can start implementing our code. So we can change this so that we can use this as a AI controlled game. So let me show you the overview from last time. So last time I told you that we need a play step in our game, and this gets an action, and based on this action we then take a move, and then we must return a reward, the game over state and the current score. So first let's write down all the things that we need to change here. So first we want to have a reset function. So after each game, our agent should be able to reset the game and start with a new game. Then we need to implement the reward that our agent gets. Then we need to change the play function so that it takes an action and then returns computes the direction. Then we also want to keep track of the current frame, or let's call this game iteration. And for later, we also need to have a change in the if-is collision function to check if this is a collision. So first, let me go over this code quickly. So what we do here is we use Pygame. Then for the direction, we use an enum. Then for the point, we use a named tuple. And then here I created a class snake game. And here we initialize the things we need for the game. So here we initialize the game state, for example. For the snake, we use a list with 3 initial values. And the head is always the front of this list. Then we keep track of the score, and here we have a helper function to place the food. And we already have a function that is called playStep. And then if we go down to the very end, so here we have our game loop. So while this is true, we take a game or a play step, and we get the game over state and the score. So this playStep function is the most important one. So here first right now we grab the user input, so the key we press. Then we calculate a move based on this key. And then we update our snake and check if we are game over. And if we can continue, we place the new food or check if we eat the food. And we update our UI with this helper function, update UI. Then here we have this helper function is collision, where we check if we either hit the boundary or we run into ourselves. And then we also have this helper function move, where we get the current direction, and then based on this direction we simply calculate the new position of the new head. So that's all what is done here. And now let's change a few things. So the first one, I want to change the class name to say Snake Game AI to make it clear that this is a agent controlled game. And now, so the first thing we want is the reset functionality. So in here, I already have this comment where we init the game state. So now we want to refactor all of this into a reset function. So we create a new function, define, and then let's call this reset, and it only gets self and no other arguments. And here we can grab all of this code and then simply paste it in here. And in our initializer, we then call self.reset. So this is the first thing we need. Additionally, we want to keep track of the game iteration or frame iteration. So let's call this self.frame iteration, and in the beginning, this is just 0. Then this define place food can stay as it is. And now we need to change the playStep function. So first of all, if we have a look at the overview, here I already told you that now we need to give this the action from the agent, and we need to return a reward. So let's start by using this action parameter. and here we grab the user input. So actually right now we can get rid of this. So the only thing we still check if we want to quit the game. And now here we already have this helper function where we move in the current direction. So actually what we change here, now this move function doesn't get the direction from the user input. So now here it gets the action, and then we have to determine the new direction. So we do this in a second, but first let's only change this. And then here we call this self.move with the action. And then we update the head. Then we check if we are game over or not. And we also need the reward. So we simply say reward equals 0. And let's go back to the slides from last time. So the reward is really simple. Whenever we eat a food, we say +10. When we lose or when we die, then we say our reward is -10. And for everything else, we just stay at 0. So we initialize the reward with 0. Then if we have a collision and game over, then we say our reward equals to -10. And we want to return this as well. So return the reward, game over, and self.score. And here we check only if we have a collision. So here I actually want to do another check. So if nothing happens for a long time, so if our snake doesn't improve and doesn't eat the food but also doesn't die, then we also want to check this. And if this happens for a too long time, then we also break here. So we can say or, and then here we say if self.frame iteration. And if this gets too large without anything happening, then we stop here. So here I use this little formula. If this is greater than 100 times the length of our snake, so remember this is a list, then we break. So this is also like this, then it's dependent on the length of the snake. So the longer our snake is, the more time it has. So, but then if it gets larger than this value, then we break. And of course we have to update the self.frame iteration, and we can simply do this here at the beginning. So for each place step we say self.frame iteration plus equals 1. And when we reset it, then we reset it back to 0. So this is here, and then if we stop, we have the reward -10. Then here, if our head hits the food, then we eat the food, so our score increases and our reward is set to +10. Then we place a new food and say otherwise we remove the last part, so we simply move here. Then this can stay as it is, the update function, and at the very end we also want to return the reward. Then for the isCollision function we need a slight change. So here I only check for self.head, but later to calculate the state or the danger which I told you about. So if we have a look at the state, so here we calculate the danger. So if we are, for example, if we are here at the corner, then we have a danger at the right. So for this, it might be handy if we don't use self.head inside here, but if we give this function a point, so this gets the point argument, and let's say by default this is none. And then here we simply check if the point is none, then we set the point equals to self.head. So inside this, where we call this with no argument, it can stay as it is. And then here, of course, we have to change self.head to, this is now our point. So here, if we hit the corner, point here and point here and point here, then we have a collision. And here, if our point is in the snake body, then we also have a collision, and otherwise we don't have a collision. All right, so the update UI function can stay like this. And now for the move function, here we need to change some things. So now we get a action, and now based on this action, we want to determine the next move. So if we go back to the slides, so here we designed the action like this. So it has 3 values. 1, 0, 0 means we keep the current direction and go straight. 0, 1, 0 means we do a right turn, and 0, 0, 1 means we do a left turn. So this is dependent on the current direction. So if we go right and do a right turn, then we go down next. If we go down and do a right turn, then we go left next, and so on. And left turn is the other way around. So now we want to determine the direction based on the action. So let's write a quick comment. Here we have straight, right turn, or left turn. So to get the next direction, first I want to define all the possible directions in a clockwise order. So we say clockwise equals and then a list. And here we start with direction.right. So here remember, for the direction we use this enum class. So it has to be one of those directions. So our clockwise directions should start with direction right. Then from this on, the next one is direction dot down. Then we have direction dot left. And as last thing, we have direction dot up. So right, down, left, up. This is clockwise. And then to get the current direction, or the current index of the current direction, we say index equals, and then we can say clockwise dot index, and then the index of the self dot direction. So we are sure that this has to be in this array because the self direction must be one of those enum values. And then we check the different possible states, so these ones. So for this we can use NumPy, and I guess we have to import NumPy first as NP, and then we can use it. Here we can say if NumPy, and then we use this function array equal, and then here we put in the action and the array that we want to compare. So if this is equal to 1, 0, 0, then we go straight, or we keep the current direction. So we simply say our new direction equals, and then clockwise of the index, and then remember the index is just the index of the current direction. So here we basically have no change. Then we say elif, if our array, if NumPy array equal, if the action equals to 0, 1, 0, then we do a right turn. So this means we go clockwise. So if we go right, then the next direction would be down. If we go down, then the next direction would be left. And if we go left, then the next direction would be up. So here we say index equals, or this is our next index actually. And here we say this is the current index plus 1 but then modulo 4. So this means if we are at the end up and then do the next one, if we have index, so this is index 0, 1, 2, 3, and then if we have index 4, modulo 4 is actually again index 0 again. So from this we do a turn and then come back at the front again. So this is our right turn. So now this is the next index, and now our new direction is clockwise of the next index. And then otherwise we can simply use else here and actually change this to an elif. So now this is the last case. So it has to be here, it has to be 0, 0, 1. And if this is the case, then let's copy and paste this in here. Then our next index is the current index -1 modulo 4. So this actually means we go counterclockwise. So we do a left turn. So if we start with right, then the next move would be up, and then the next would be left, and then the next would be down, and then right again, and so on. So now this is our new direction, and then simply we say self direction equals new direction, and then we go on. So here we extract the head, and then here we have to check if self dot direction now is right, then we increase the position of x, and so on. If we have the left direction, then we decrease x, and if we go down, then we actually increase y. So the y starts at the top at 0 and then increases if we go down. So if we go down, then we have to increase y, and if we go up, then we have to decrease y. So if self direction equals up, then y minus equals the block size. And by the way, the block size is just here a constant value of 10. So that's how big our one block of the snake should be in pixels. So yeah, this is everything we need here in the move function. And now here we don't need this anymore. So this is actually no longer working with a user input. So you can just delete this, and then later we control this class from the agent and call this playstep function. So yeah, for now this is all we need to implement the game, and I hope that you enjoyed this tutorial, and then see you in the next part where we implement the agent.